For sure, you have heard about the Himalayas and Mount Everest. I probably learned about it in kindergarten, and the term the world's highest mountain is always circling around, always being mentioned in the same breath as the mountains themselves. Flying over Asia, it is hard to miss this massive white curve clearly separating the contrasting landscape. But thinking about it, why is the world's tallest mountain here? And how did it form? Well, the Indian subcontinent once crashed into Asia. And that's it. There's nothing more to it. Or so I thought. Until one night, while I was reading about the Tibetan Plateau, looking at a satellite picture, this clear white boundary is the Himalayas. Its name appropriately explains the look, abode of the snow. To the north, the Tibetan Plateau and the Tarim Basin, and to the south, a lush green piece of land, in stark contrast to the north. Peeling back the surface, and we see the geologic plate boundaries. The southern edge of the Tibetan Plateau aligns with the boundary. This is where India and Eurasia meet. But to understand how these continents met, we need to travel back in time to the early Cretaceous period, the final chapter for the dinosaurs, about 140 million years ago. 140 million years might sound like an eternity. But think about it like this. Let's compare the history of the Earth, about 4.5 billion years, to a normal year with 365 days. Well, let's say Earth was formed at midnight on January the 1st. And now we're on the very last day of the year, December 31st. So in this timeline, 140 million years ago would be around the afternoon of December 20th. That's why for Earth, 140 million years is not a long time. Back then, the Himalayas and the entire Tibetan Plateau did not exist. The land we now call the Indian subcontinent was in a completely different place. Instead of being in the northern hemisphere and surrounded by water on three sides, India was down south and had neighbors we know today as Australia, Antarctic, and Madagascar. What about Eurasia? It was already up north. Together with North America, it formed the ancient supercontinent Laurasia. Separating India and Eurasia was an ocean called Tethys, named after a titan in Greek mythology, the sister and consort of Oceanus. But over time, India left its neighbors and began a journey northward. But how can continents move? It might be hard to imagine, but the land we stand on is not as stable as it seems. Think of the continents as floating ships, driven by movements deep inside the earth. These gigantic rock ships travel around the earth, floating on molten rock. And they like to play bumper cars, or rather, bumper ships. So what happens when two continents collide? While traveling north, the Indian plate was moving up to 18 cm per year, which is equal to 1.5 cm every month. For comparison, most continents today drift 1.5 cm every year on average. So if the rest of the world now walks, India was basically driving a car, moving 12 times as fast. Before the Indian plate arrived, two smaller continents collided with the Eurasian plate first. So there was not one, but three collisions that formed the Tibetan Plateau. Eventually, the Indian plate collided with the Eurasian plate. And when did that happen? The exact time of the collision is still the subject of scientific debate. But it likely occurred around the time the dinosaurs went extinct, around 65 million years ago. So what exactly happened? First, the northwestern corner of India made contact with the Eurasian plate. After that, the Indian plate began rotating counterclockwise. Eventually, fully colliding with Asia around 40 million years ago. For lots of us, the story we were told ends here. What might have been the biggest collision between continents on Earth lifted the highest plateau, bringing with it the highest mountains. Case closed. Or is it? Let's take a closer look at the plateau's profile. Something doesn't quite add up. The Himalayas don't just rise higher than the plateau, they tower over it, with peaks reaching nearly twice the average height of the plateau, while the plateau itself averages around 4,500 meters in height. The Himalayas have many peaks that reach more than 8,000 meters. Mount Everest stands at a staggering 8,848 meters, almost double the average height of the plateau. That is strange, isn't it? How did it grow so tall? If the collision simply lifted the land, we'd expect a gradual rise from north to south, right? Instead, we see a sharp, dramatic rise. How could that be? What could be hiding behind this? To find more clues, we need to zoom out a bit. The Indian plate moved across the Tethys Ocean to collide with the Eurasian plate. Today, there is still a massive ocean in that area, the Indian Ocean. And what do oceans do? They provide a tremendous amount of water. Have you ever heard the term monsoon from the news? The Asian monsoon is a seasonal wind that brings heavy rain to South Asia during summer months, typically from June to September. The word monsoon originates from the Arabic word for season, emphasizing its predictable cycles. Every year, the monsoon carries an enormous amount of water northward, but standing directly in its path are the Himalayas. These towering peaks force the moisture-laden winds to rise, making them release rain and snow. This relentless downpour breaks down rocks, glaciers, and rivers, then carry them away. It has been measured that some glaciers on the Himalayas move up to 4 meters a day, sculpting the valleys in the process. By doing this, the weight of the mountains is reduced, slowly but surely. This process is called erosion. But how is erosion related to the height of the mountains? Year after year, erosion wears the mountains down. It lowers them and flattens the landscape over time. So erosions can't make the mountains taller, right? Well, let's go back to the ship analogy for a moment. The land we stand on is kind of similar to ships in water. A heavily loaded ship sits lower in the water, but as you throw cargo overboard, it becomes lighter and rises. The Himalayas work in a similar way. That's why as erosion strips away sediments, this ship, made from rocks, becomes lighter and slowly lifts to achieve isostasy, the state of gravitational equilibrium. This process of losing weight and being lifted, combined with the ongoing collision between tectonic plates, keeps the Himalayas rising. By blocking the monsoon, the Himalayas act as a massive barrier that reduces rainfall and therefore erosion on the Tibetan Plateau, which explains why the Himalayas are so much higher than the plateau. All these forces working together created today's landscape. The Himalayas divided the region into two completely different worlds: lush, fertile plains to the south, and arid, high-altitude plateau to the north. These different landscapes helped shaping the lives of the people on both sides. In the south, the water from the monsoon feeds the mighty rivers of India, Nepal, and Bangladesh, supporting vast farmlands. Meanwhile, on the Tibetan Plateau, where the land is often harsh and dry, people have adapted by herding yaks, relying on barley as a staple crop, and developing unique foods like butter tea and tsampa. roasted barley flour. Even now, the Indian and Eurasian plate are still colliding with a speed of around 5 cm per year, pushing the Himalayas upward by about 5 mm annually. At the same time, relentless water from the monsoon carves the mountains down, therefore making the land lighter and making it rise even more. All of this maintains this incredible balance of creation and destruction that has shaped this landscape for millions of years. Our Earth is the stage for lots of stories like this. The Himalayas are only one example. Wherever we are, the land surrounds us shapes our lives while also being shaped by us. Upon closer inspection, there are always interesting things to be discovered. This has been the first report by the Earth Inspector. Thanks for watching, and see you next time at a great lake in Europe.